So we have a railroad car, mass m is moving with a speed. It says u, it's labeled incorrectly up here. It's u, but let's just call it v0. Collides with and connects to a second rail car of mass 3m initially at rest. So this v0 equals 0. How do the speed and kinetic energy of the connected arcs compare to those of the single car before the collision? So what we know about the speed is this momentum of this block is now going to be shared with this new system that has a mass of 4m. So the speed is going to be less. So we can take off this one and this one and this one because it's not the same and it's not greater. It's less. And if the kinetic energy is 1/2 mv squared, since the velocity is decreasing, the velocity term is decreasing, its effect is larger because it's a squared term. So even though the mass goes up, the velocity is going to go down, and since it's squared, it's going to bring about a bigger change. And so that's why we're looking at less kinetic energy, not the same. Now we can go through a proof of sorts about this. And so we could do our conservation of momentum to start this. And so we have mv0, and then afterward we have 4m, and the new velocity, which is unknown, we'll just call v. And we have m on both sides, so we can divide those out. And we're left with 4v equals v0, or the final velocity is 1/4 of the initial velocity. So we just proved that it's less. The v after is less. Now we look at the kinetic energy. The kinetic energy initially is 1/2 mv squared. And the m is m, and the v is v0. So that's the kinetic energy before. Now afterward, we have this system that's stuck together of the carts. The mass is now 4m, but the velocity is 1/4 v0 squared. So we have 1/2 4m all over 1/16 v0 squared. So this is 1 and this is 4. And we can see this is 1/8 v0 squared. 1/8 mv0 squared. So when you compare this 1/8 mv0 squared to 1/2 mv squared, it is less.